Hello students, now we start the lecture for CET and today's topic is mechanical properties of fluid. In last lecture we see about the surface tension, surface energy, then intermolecular forces. Today we study about the relation between surface tension, surface energy and angle of contact, etc. See now the topic relation between surface energy and surface tension. For this we perform an experiment, that is, consider the rectangular frame PQRS. This is the rectangular frame made up of wire. This frame is dipped in soap solution so that this film PQRS is formed. Now this QR, it is the wire and which easily slide on this frame. See, suppose this is the film, and if we move this rod, this QR towards left, then the film is, or there is increase in area. Now for this we see about, that is, we study to increase the surface area, to increase the surface area, To increase the surface area, this QR moves towards right. There is a force equal and opposite, that is F is equal to F dash, but it is in the opposite direction. Area is increased. This is the L is the length of this is the length, and dx, the frame is displaced through distance dx. Therefore, the increase in surface area can be dA, suppose. Now we know surface tension is given by, surface tension is equal to force per unit length. Now in this case, force is equal to T multiplied by L. In this case, two surfaces are formed for this soap solution and we get, that is, 2T into L, 2T into L. Now this QR, it is pushed towards the left, then there is increase in area, and F dash, it is the force which is equal and opposite, which is 2TL. To move this QR towards left, the work is done, and the work done, it is dW through distance dx. See here, the wire QR, it is moved towards the left, the work is done, and the work done is W through the distance dx, Now see, we know work done is equal to force multiplied by displacement. The force is, now here the force is F dash and the displacement is dx. Now substitute the value of F dash here, that is 2TL dx. Now in this case, the work done dW is equal to T into 2L dx. This is the C, L is the length, dx is the breadth here. See, L is the length, this is the breadth, this is the area. That is, we can say 2L dx, it is the increase in area. We can substitute here, that is dA is equal to 2L dx. Therefore, this increase in area we can substitute here and we get dW is equal to T into dA. See, this is the work done. And it is stored in the form of energy, potential energy, and it is called as surface energy. Therefore, we can write here surface energy is equal to surface tension surface tension multiply by increase in area. Increase in area. Increase in area. Thus, we can say that this surface energy is equal to surface tension multiplied by energy increase in surface area. Therefore, surface energy is equal to surface energy is equal to surface tension multiply by dA. Therefore, we can say that surface tension is equal to surface tension is equal to surface energy divided by increase in area. And surface tension, therefore SI unit of surface tension. We can find the another unit of surface tension, that is surface tension T is equal to surface energy divided by area, and the unit of energy it is joule and area is meter square. Therefore, another unit for surface tension it is joule per meter square or joule meter minus 2, joule meter raised to minus 2. This is another unit of this surface tension. Now we see the angle of contact. Next topic, angle of contact. Angle of contact. The angle of contact, see, suppose we consider the liquid. Now in this liquid, suppose we consider here water. In case of water, see, suppose we consider this is the water. In another beaker, there is a mercury. Suppose here we can say it is impure water. And here we consider mercury. In case of impure water or kerosene, the free surface of liquid it is concave. In case of mercury, the free surface of liquid it is convex. Suppose we take a capillary tube and we see the surface. Suppose there is a capillary tube, then the surface is like this, it is convex. Suppose the water rises in capillary and the free surface of liquid it is concave. See, in this case, suppose this is capillary, the free surface of liquid it is concave. In case of mercury, the free surface of liquid it is convex. Now see what is the property here. Now this is the free surface of liquid. We take the example of impure water or kerosene. In this case, suppose we draw the tangent here. Then theta denotes the angle of contact. Now in case of again mercury, suppose we draw the here tangent to this free surface and it gives theta, and theta is the angle of contact. In both cases theta is angle of contact. Angle of contact. Then we can define this angle of contact. See here, this is the free surface of liquid, this is the tangent, and this is the point of solid surface. Then we can define angle of contact is angle between the tangent to the free surface and the point where this liquid is in contact. Theta is angle of contact. In case of mercury, theta is angle of contact. Now see, suppose we consider impure water, kerosene, the angle of contact, it is C. Suppose this is the normal, this angle is 90 here and this angle is less than 90. The theta is less than 90. Then we can say that the theta is acute. Theta is acute. If the angle is less than 90, it is called as acute. That is, in case of impure water or kerosene, the angle of contact is less than 0, it is acute. We can say that the angle of contact for impure water or kerosene, the angle of contact is acute, that is, it is less than 90. In case of mercury, see, the angle is, suppose 90 is here, it is greater than 90, therefore theta is greater than 90. In case of mercury, the theta is, angle of contact is greater than 90, we can say that the theta is, angle of contact is called as obtuse. In case of kerosene or mercury, the free surface of liquid, it is concave. In case of mercury, the free surface is convex. That is, the angle is greater than 90 degree and it is called as obtuse. Now we see the effect of angle of contact. See here, see, consider this is the figure A and figure B. We can say that angle of contact, suppose we consider the liquid drop. Suppose liquid is dropped on the ground, we get the drop. In case of impure water or kerosene, this is like this, and in case of mercury, this is the drop. This is the drop. In case of kerosene or impure water, that is, angle is less than 90, angle is theta is acute here. See T1. T1, it is the force of surface tension. Force of surface tension. Due to, see here, this is the solid surface and this is the liquid surface. That is, we can say that it is the force of surface tension due to solid liquid interface. Now T2. See, this is the force T2. That is, we can say that T2 is force of surface tension. See, in this case, T2 is, this is solid surface, this is air. This is air, this is solid, then this is liquid. T2 is force of surface tension between air and solid interface due to solid and air interface. Now the T3. See, in case of T3, it is again the force of surface tension. Here it is liquid, here it is air. Therefore, we can say that T3 is force of surface tension. Force of surface tension due to this liquid and air interface. Liquid and air interface. See, from this we can write an equation. See, T1 it is towards right, T2 it is towards left, and T3 it is through angle theta. Now here we consider cos theta, the component cos theta, and this is the coincide side, therefore it is T3 cos theta. Suppose we consider here cos theta is equal to this side x divided by this T3, therefore we can write T3 cos theta for this unknown side, and it is T3 cos theta. By vector diagram, we can say this T1 and T3 cos theta, it is along the same direction, while T2 it is in the opposite direction. Therefore, we can say that T1, T3 cos theta, it is in the towards right, and T2 it is towards left. From figure we can write T1 plus T3 cos theta is equal to T2. Why this is so? See, the direction of this force is, it is same, or it is along the T1. These are towards the same direction. This is towards the opposite direction. Therefore, from figure we can write T1 plus T3 cos theta is equal to T2. Rearrange the equation, we get T3 cos theta is equal to T2. This T1 makes, or it becomes minus T1 cos theta is equal to T2 minus T1 and divide by this T3. From this equation, we can find the angle of contact may be positive, may be negative, or may be equal to 1. See, we consider the cases. Case 1, if T2 minus T1, it is positive. T2 minus T1 is positive, that is T2 is greater than this T1. T2 is greater than T1. The whole factor is positive and the angle of contact is acute. The angle of contact is acute. Now in second case,